As I already have been introduced by Gilson, I'm Michael Sommer from SOMMER Messtechnik from Austria. And I would like to show you today a couple of new solutions to measure discharge in rivers with the focus on non-contact technology. So non-contact measurement of discharge in rivers. First of all, I would like to start with a small introduction of our company. Our company was founded 30 years ago by my father, Mr. Wolfram Sommer, and we're based in Austria, not Australia, so we're from Europe. And the focus is since 30 years to develop very innovative, very advanced, high-quality measurement products for the field of meteorology and hydrology. In meteorology, we mainly focus on snow and ice measurement because in many hydrological environments, water starts in the snow in the mountains. Here in Brazil, of course, it's a little bit different, so we're going to focus just on the hydrological sector. We're still a family-owned company. We have about 50 people and we have 2 offices all around the world. We have one in Kuala Lumpur, Asia, and our main office in Austria. As I said, we work in several business fields, several areas of activity. So mainly in meteorology, we work in snow and ice. In hydrology, we work in discharge measurement, water level measurement of rivers, but we also do complete early warning systems for flooding and such. But we also have a section where we do industrial water flows in sewer systems, industrial effluents of factories or agriculture as well. Especially here in South America, we do a lot in mining industry. The mines use a lot of water. Many mines, especially in Argentina and Chile, they also use melting water from glaciers as well as snow for their process, and so we find a huge market in the mining industry as well. And our last application is ice detection, so we have a special, very unique sensor where we can detect icing on airports, on roads, trains, and many other applications. But as I said, today we're going to focus on hydrology and have a quick overview about the products that we're going to deliver or that we're going to manufacture in Austria. So we do water level sensors, especially based on radar technology. We're going to do water surface velocity, so we have sensors that can measure the velocity of the water surface. And then we have non-contact discharge sensors, what will be the focus of today's session. Here we have 2 different systems. We have a stationary solution that will be installed in one place and collect data 24/7. And we have a portable solution. So we can take it to the river, we can measure the river without touching the water, and we will get the result right away on our laptop or tablet. And last but not least, we also have discharge measurement for rivers with the tracer dilution technology. What is very nice technology, very unique instrument, and especially for the measurement of turbulent rivers and mountain streams. As I already said, the focus is on discharge measurement, and we use 2 different technologies. We have contact-free radar sensors, one stationary, one portable. But we also use the tracer dilution method, what is an older technology invented in the 60s. But we put all these calculations that have been done in the past manually, we put it into our software, and so we developed the TQ Tracer, what is again a mobile device. We're going to start with the RQ30 as a stationary device installed on a bridge, on an arm, or on a cable. The non-contact technology has obvious advantages. For example, it's much easier to install than systems that are based in the water. So we just hang it on a bridge, hang it on a cable, or we install a small arm. Because we're not in touch with the water, the sensor is completely maintenance-free. There is no cleaning, there is no maintenance that we have to do. As well as during flood time, the sensor is very reliable and is not in danger of any debris and of any damaging from the flood or anything that flows inside the water. Now I would like to show you how can we get the discharge with not touching the water. So first of all, the equation that we use inside the RQ, most of you are very familiar with it, means mean velocity of the water multiplied by the area of the water. Funny thing, we don't measure the mean velocity and we don't measure the area. So how do we get there? It's actually quite simple. First we measure the water level. So the RQ30 has a water level sensor inside, it's based on radar technology. And then we have to get the cross-section profile. We enter the cross-section profile into our software. We download this information down to the sensor, to the RQ30, and then the RQ30 automatically will calculate the area of the river. So we have the first important parameter. Now, secondly, we measure the local velocity, called here, means the surface velocity of the water. But what is really interesting is the mean velocity of the water. In order to get from the surface velocity to the mean velocity, we need so-called K-factors. These factors, they are created by our hydraulic model that is also in the software. So when I input the cross-section shape, the software will calculate me different K-factors for different water levels. This means if we have very low water level, these K-factor will be different than if we have very high water levels. So the K-factor is basically the relationship between mean velocity and surface velocity. With all this information, we download this information to the sensor, and therefore all the calculation, everything happens in the sensor, and the RQ30 will output already the finished discharge. So now a very small comparison between conventional measurement methods or systems that are in place and used all around the world, and this is the water level measurement using a rating curve. Most of you are familiar. We measure the water level, and then over time we do a reference curve, and then we tell the data logger or the system at this water level we should have this discharge, what is true or not. So the advantages of the RQ30 are pretty clear. We don't need the rating curve. What does this mean? A rating curve, in order to create a good rating curve, we need about 2 years. This means we install a station, we invest a lot of money into a station, and then we have to go 2 years continuously to decide and make references. With an RQ30, we install a sensor, we put in the cross-section profile, and from day one, from the installation, we will get accurate and reliable discharge data. We will also have a much higher accuracy because the RQ30 not only measures the water level. Rivers are very dynamic bodies. That means the velocity changes constantly. And this also means the velocity can change even at the same water level. What we see a lot here in Brazil, this is called hysteresis effect. And there are a lot of other dynamic processes happening in the water that you cannot see if you only measure water level. For example, during a flood or during an increase of water level, before the water level increases, the velocity will increase. Because it's simply much easier for the river to go faster than to go higher. There was also a case study that I would like to show you. I'm going to jump this. From NOAA in the United States. So they had a couple of tropical storms all over the United States. This is just one example from Oklahoma. And because of these storms that came very, very quickly and caused very heavy flash flooding, they started a project called the Anchor Project. What basically means they would like to monitor stormwater rivers, and they said the only way to do this is non-contact based. So they came to us, and in 2017 we installed the first few RQs for them, and one in Falls Creek, Oklahoma. 2 months later we had a flash flood, exactly this site, And this time, the XXIII could collect all the data from beginning till the end of the flash flood, because the sensor was installed outside of the water, was not damaged, didn't get dirty, and could collect very reliable data. Looking into the data, NOAA found out that in this case, in this river, 1 hour before the water level increased, the velocity increased. So that means now, with monitoring water level and velocity, they have 1 hour more lead time for alarming evacuations, preparations, and things like this. So with monitoring velocity and water level, we simply have more information about the river, and therefore we can do earlier warning and earlier detecting flood events. Now we're going to focus on some pictures from all around the world. We can see here pictures from China, what is one of our biggest markets. We have about 5,000 installations only in China. We can see a river where the water level increases during typhoon season about 15 meters. So the flow conditions are totally different between the lean season and the flood season. We can measure the discharge with the same sensor, same setting. In here we have a nice picture from Austria. The customer spent a lot of money for the gauging house, but not for the installation of the sensor. So he decided to put the sensor on the side of the river. As I mentioned earlier, we use a complex hydraulic model in the background, and therefore, if we tell the software the sensor is not in the middle of the river, he's on the side of the river, the software will compensate for this position. Here we can see in the top 2 rivers from Austria again, and very controversial rivers. So we have very low water, very calm river, slowly flowing. And on the other side we have very turbulent, white water river. And also these 2 situations are absolutely no problem for us to measure the discharge. This is an installation in Papua New Guinea, a part of the world where they still have cannibals. So the infrastructure is very bad in this country, but still they want to measure the water flows. And so we see a river with, a river with about 100 meter width, and without any bridge and without any infrastructure. So the customer just pulled a cable over the river and installed the complete hydrological station on the cable, what is possible as well. Now, quickly, as I said, we also have a portable device. The one we saw, XXIII, is stationary, installed on a bridge in one place, and now we quickly talk about the mobile device. We call it the RP30. The P stands for profiler. So we not only measure the velocity in one point, we can now measure the velocity in several points on the water, as you can see here on the picture. Then again, together with the cross-section profile and the water level, we get the discharge right away on our computer or on our tablet. And this all works. We can see here the most usages. Oh, now it comes. Okay. So the first thing we do when we go to the site, we usually get the cross-section profile, and then we enter this into our software, as you can see here. After doing this, the next step would be to get the velocities. So, as I said, we have here the RP, and we measure now the velocities in several points over the water surface. This is especially interesting if the hydraulic conditions are very difficult, or if we don't have a station installed there. That means if we have high flooding, really high water, where it's really dangerous to measure with any other technology, we take the RP there, we do our measurements, we wait till the flood has retreated, we get the cross-section profile, and we will know how much water was flowing during the flood. Here we can see the software, we can see the velocity. Sorry. Okay, it starts again. Okay. Anyway, we could see the velocity profile and the cross-section profile combined, and then in the end the software will calculate the discharge and the area for each measurement, and will combine it and will tell us the total discharge of the measurement. As you can see here, big flood, we're very safe up on the bridge, same here, and of course in many countries of the world, if we don't have to touch the water, we are safe from other dangers, snakes, alligators, crocodiles. Okay, thank you very much.